of cooling. Here is the first problem. A copper ball originally at 80 degrees Celsius cooled down to 60 degrees Celsius in 20 minutes. If the temperature of air is 40 degrees Celsius, what will be the ball after 40 minutes from the original? Here we have to solve the problems according to Newton's law of cooling. So first take the given data. Here they have mentioned a copper ball originally at 80 degrees Celsius. Here first at room temperature the copper ball will be at 80 degrees Celsius. If we cool down that copper ball, that reduced to 60 degrees Celsius in 20 minutes. If the temperature of air is 40 degrees Celsius, then we have to find what is the ball after 40 minutes from the original. That is, what is the temperature of the ball after the 40 minutes from the original value. Here first take the given data. Here they have mentioned the copper ball originally at 80 degrees Celsius. That means at t is equal to 0, we get the value of temperature of a copper ball as 80 degrees Celsius. Here they have mentioned the temperature of air is 40 degrees Celsius. That is, the temperature of air we can take it as T0. T0 value is temperature of air, that is given by 40 degrees Celsius. Here the copper ball originally at 80 degrees Celsius means at time T is equal to 0. The value of copper ball, that is the temperature of a copper ball is 80 degrees Celsius. At time 20 minutes, the copper ball, it reduced the temperature to 60 degrees Celsius. That means at time 20 minutes, the temperature of a copper ball is 60 degrees Celsius. We have to find what will be the ball after 40 minutes from the original. That means what will be the ball's temperature after 40 minutes. That is, we have to find at time 40 minutes what is the temperature of a ball. That is, we have to find the T value. Let us suppose T be the temperature of a copper ball and T0 be the temperature of air at time T. We know that from Newton's law of cooling, the temperature of a function at any time T is given by T is equal to T0 plus lambda into exponential power minus K into T. Here, to find the temperature of a ball after 40 minutes, we have to find, in the first step, we have to find the lambda value. For that, substitute T0 value. They have given the temperature of a air value T0 is given by 40 degrees Celsius. Substitute that value here, we get as T is equal to T0 is 40 plus lambda into exponential power minus K into T. Call this as equation number 1. Next step, we have to substitute the given data over here. That is, at the time T is equal to 0, that is initial at time T is equal to 0, the temperature is given by 80 degrees Celsius. So, at T is equal to 0, substitute T value as 80 degrees Celsius. So, substituting T value as 80, which is equal to 40 plus lambda into exponential power minus K into T value is 0. Here small t is the time and capital T is the temperature of a copper ball. We know that at time T equal to 0, temperature of a copper ball is 80 degrees Celsius. So, substituting T value as 80, we can take this as 80 is equal to 40 plus lambda into exponential power minus K into here small t is time, that is 0. You know that exponential power 0 is 1. Hence, we get this value becomes 1. Hence, we get lambda value as, here take this 40 to the left hand side, 80 minus 40 is 40. Hence, we get the value of lambda as 40. Here, first step is completed. That is, to find the lambda value means substituting the given data. Here, they have given the temperature of the air is given by 40 degrees Celsius. Substituting that value. Again, we have to take the given data at time T is equal to 0. The temperature of a ball is 80 degrees Celsius. Substituting T as 80 and at time T is equal to 0, we get a lambda value as 40. Once we obtain a lambda value, substituting this lambda value over equation 1, we get, now we have to substitute lambda value as 40 over here. We get the equation 1 as T is equal to 40 plus here lambda is 40 into exponential power minus kt as it is. So, the equation reduces to this. Call this as equation number 2. Here, we obtain this equation at the data t is equal to 0. We get a value of t as 80 degrees Celsius. Next, we have to take this value, that is at time 20 minutes, t is 60 degrees Celsius. That is at time 20 minutes, the temperature of the ball here reduces to 60 degrees Celsius. Hence, the equation 2 reduces to, here in the place of capital T, we have to substitute as 60, which is equal to T naught is 40 plus lambda is 40 into exponential power minus K into here T is, that is small t is 20. Next step, take this 40 to the left hand side, 60 minus 40, that is 20, which is equal to 40 into exponential power minus 20 into K. Take this value to the left hand side, that becomes 20 divided by 40. We know that 20 divided by 40 is 0.5, that is 0.5. That's our exponential power minus 20k value. We are doing this procedure because first step we have to find lambda value. Next step we have to find k value. Further, we have taken the second data, that is at time t is equal to 20 minutes, we have to substitute the temperature of a ball is 60 degrees Celsius. That is 60 is equal to 40 plus 40 into exponential power minus 20k. Take this 40 to the left hand side, 60 minus 40 is 20, which is equal to 40 into exponential power minus 20k. Hence we get exponential power minus 20k value as 0.5. Next step, we have to take log on both the side. We get here taking log on both the side means we get as log of e power minus 20k. Here we have base e, which is equal to log of 0.5 to the base e. We know that from the logarithmic formula, log of m power n, we can split it as n log m. So this is of the form log m power n. So we can split this value as minus 20k into log e to the base e. Also we know that log e to the base e value is 1. Hence we get the value in the left hand side as minus 20k. That is minus 20k. This is of the form log of m power n. We can split it as n log m, that is minus 20k into log e to the base e. Also we know that log e to the base e value is 1. So substituting that value we get as minus 20k in the left hand side, which is equal to log of 0.5 to the base e. We know that log of x to the base e, we can write it as ln of x. Log is different, ln is different. Log of x to the base e, we can write it as ln of x. Here this is of the form log of x to the base e. Here x is 0.5. Hence we can substitute as ln of 0.5. Log of 0.5 to the base e is ln of 0.5. We can take, using the scientific calculator, we can obtain the value of ln of 0.5 as minus 0.6931. Ln of 0.5 value is minus 0.6931. That is our minus 20k value. Take this minus 20 to the right hand side, that becomes divided by minus 20. Hence we get k value as minus 0.6931 divided by minus 20. We get a value of k as 0.03465. This is a value of k. Once we substitute the second data value, that is t is equal to 20 minutes, t value becomes 60 degrees Celsius. In equation 2, we get a value of k. Once we obtain k value and lambda value, substitute in equation 2, we get as equation 2 is t is equal to 40 plus lambda is 40 into exponential power of, here k is this value, that is minus k value 0.03465 into t. Here we have to write the positive or negative sign carefully. This is equation 2 is t is equal to 40 plus 40 into exponential power of minus kt. Here k value is 0.03465 into t. This is a value of t. Also they have given, finally we have to find the value of this t, that is the temperature of a copper ball when the time is 40 minutes. At time t is equal to 40 minutes, we have to find the temperature of a copper ball. For that, substitute here t value as 40. We get as t is equal to 40 plus 40 into exponential power of minus 0.03465 into, in the place of small t, we can substitute as 40. That is t value is 40 minutes. We have to find the capital T, that is temperature of a copper ball at time 40 minutes. So in the place of small t, substitute as 40, we get as t is equal to 40 plus 40 into, here exponential power, multiply 40 inside, minus 0.03465, we get a value as minus 1.384. Here exponential power of, multiply this value, we get as minus 1.384. Next we calculate this value 40 plus 40 into exponential power of minus 1.384 in a scientific calculator. We get a value of t, that is temperature of a copper ball At time 40 minutes, we get as 50 degrees Celsius. This completes the problem. We shall move on to another problem so that you can understand in a better way.